let's look at recursive formulas with these geometric sequences. We just keep plowing ahead here. We're close, guys, to the finish line. Well, part one. Anyway, let's look at recursive formulas. Just recall that anytime we're dealing with a recursive formula for a sequence, it's different than the explicit formula. So you got to keep this straight as to the terminology and what they're looking for when solving these problems. A recursive formula always will involve what is called the previous term. It's notated using a sub n minus 1. Anytime you see this a sub n minus 1, your brain should automatically think the previous term. And so a way of thinking about this is this way. If I had the sequence 2, 4, 8, 16, we would recognize that we have this common ratio of 2. It's multiplying by 2 each time. That's not what's so important in this case in terms of what I'm trying to get to you in terms of the recursive formula. It's really about, well, what does previous term mean? If I'm sitting here at the third term, 8, previous term really means the one behind it would be 4. So you're going to have to logic through the notation and the math and then the terminology previous term. Think about this. If the third term is 8, you can find its previous term by writing a sub n minus 1. Well, n is 3 here. So a sub 3 minus 1, check that out. That means the previous term to term 3 is the second term. So that's how this notation is working mathematically, then to also be able to apply it logically and linguistically within this situation. So how does a recursive formula work? That's important. They're going to ask you to write the recursive formula from an explicit formula or from clues. But before we do that, tackle this example that's in the book, let's write the recursive formula for this 2, 4, 8, 16. So all recursive formulas that are geometric are of the form a sub n equal to r times the previous term. This should absolutely, this should absolutely make so much sense. And so we have to have more information, by the way. The more information we need is, well, what's the first term? Or we have to be given some type of information in the sequence, either the third term or the 8th term or something like that. We need to know, well, what's the first term to be able to generate the sequence? And I'll explain why. So anytime you do a recursive formula, we start with this r times a sub n minus 1, or r times your previous term. And that's what you should, here, just real quick. That's what you need to be thinking. Words. A sub n minus 1 means previous term. And you should read it just like that. When you're reading the formula, you should be using, instead of a sub n minus 1, you should be substituting in previous term. So the nth term, a sub n, is found by multiplying your common ratio r times the previous term. Given the first term, we need to know what the first term is. So they're going to fill in the blank here. In this case, the first term is 2. And we have to make sure then that we know that we're starting with values of n that are greater than or equal to 2. Because we're given the first term, we don't need to substitute anything in for n. You got to use values for n greater than 2 there. And just so you know, we're not going to actually use the value of n to generate our sequences or to vet these sequence rules. We're just going to simply use the notion that we have this common ratio of 2, and we're just multiplying it by the previous term to get the next term. Okay, so that's completely, totally clear as mud, I know. Let's actually write the formula and then use it to regenerate this sequence. So how does this work? We're using that general form for a recursive formula. To write its recursive formula. Okay, so here we go. We're going to go. The nth term is found by taking our common ratio. The common ratio here is 2. Make note of that. And then we're going to multiply that, and we always just write the previous term. We're taking 2 times the previous term, given that the first term in this case is 2, for all values of n greater than or equal to 2. How does this generate the sequence? Well, put in the previous term, or in this case, the first term, excuse me. We've got to put in the first term to find our next term. So the second term is going to be found by taking, ran out of space here, 2 times that first term. That gives us term 2. And now we want to find the third term. We're going to take that common ratio times 4. Remember, this is the second term. That's going to give us 8, so on and so forth. That's the application of being able to find or generate our sequence given the explicit formula. Guys, I'm going to take a little side trip here with you to finish up this part of the video, and then we'll move on to an actual example that they give you in the book, example number 5. I want you to see how an explicit formula and a recursive formula generate a sequence. If they give you the sequence equations, you should be able to generate those sequences. So here's a little side trip here. For you guys to be able to be efficient with your homework here. Let's take a look. Okay, let's say we're given the explicit formula. And we're supposed to generate that sequence. Well, you already know what the first term is. It's in the formula. So we know first term is 5. Well, then we're going to calculate to find the second one. Well, let's just do the math in our heads here. We're taking 5 times 2 to the 2 minus 1. Well, 2 minus 1 is 1, which means we're going to have 2 to the first power, or 2. So 2 times 5 gives us 10. And so we know our second term is 10. That should make sense. If the common ratio is 2, we're doubling this. The next one we should already know is going to be 20. But let's use the formula to generate that. And what I mean by that is put 3 in for into our formula. Well, 3 minus 1 is going to be 2. I'll be very specific. Won't skip any steps. Think about this. If n is 3, excuse me, is going to be 5 times 2 to the second power. Well, 2 to the second power is 4. 4 times 5 is 20. We're generating the sequence using this explicit formula. Okay, well, how does that then translate to a recursive formula? If you're given a recursive formula, how do you generate a sequence? I'm going to put this one off to the side. If they tell us our recursive formula is a sub n is equal to 2 times a sub n minus 1, 2 times the previous term, given that the first term is 5, and of course, we're going to have all values for n greater than 2, greater than or equal to 2. So if we already know our first term is 5. They gave us that. So we'll just list our as we go. So to find the second term, guys, don't put 2 in for n, please. Just go 2 times the previous term. The previous term was 5. Hey, there gives us 10. What's the next term going to be? What's the third term going to be? Well, take this 10 times 2, or 2 times 10, and that gives us 20. Sure enough, we're generating our sequence from that formula. 2 different ways of writing the same sequence, recursive versus explicit. See you guys in the next video.